Hello everyone, this is Team 10, otherwise known as Mozzarella's Team Final Project. Our team members are Lucas Cross, Chris Marin, Dean Pina Rogers, Casey Tebow, and Nellie Sarah Tom. What we'd like to talk to you today about is velocity, acceleration, and speed in video games, movies, and mobile apps. For video games, this is extremely apparent in Grand Theft Auto V. Within this game, we can see a lot of speed and acceleration taking place, especially when you start running instead of walking or start speeding off in a car that you have just stolen. In order to make these game effects seem very realistic, we have to use many equations, such as the ones that we have learned in this class. Next, we have movies, and what we'd like to talk about here is Fast and Furious. Fast and Furious, as we all know, revolves around cars. Therefore, it is extremely important that speed and velocity are both taken into account, especially as we add in effects such as cars or explosions. When things such as speed or velocity, or even acceleration, are taken out of context, the movie can have a very fake feel, which is definitely not what producers are going for nowadays. Next, we have mobile apps, and what we'd like to talk about is none other than Google Maps, which most of us use on an almost daily basis. Within Google Maps, your car is tracked by how fast it's going, so therefore, in order to make the app work correctly, we need speed. Not only that, we're going to need velocity in order to keep that speed right on track and make it look as if you were really going in that direction. For our experiment, we've decided to find out the acceleration of a skateboard versus someone running. In order to best conduct our test, we decided to go outside of building 3B and measure the ground that we decided to test upon. We found out that the area that we were going to use was approximately 3.81 meters. Once we had our distance, it was time to begin testing. In order to get a reliable time for both the running and the skating experiments, we decided to run each test 2 to 3 times. With those numbers, we would then get an average and continue on with both the velocity and the acceleration problems. Our first running test turned out to be 3.28 seconds. Our second running test was 3.23 seconds. Once we had these numbers, we added them together and then divided by 2. That ended up giving us our average, which ended up being approximately 3.255 seconds. Once we had these results, we then moved on to skateboarding. Our first skateboarding test came out to be 3.36 seconds. Our second test came out to be 2.86 seconds. We realized this was a little bit shorter than the first test and therefore decided to test a third time. Our third test came out to be 3.39 seconds. Once we had all 3 numbers, we were able to finally go forth and get the average. The average for the skateboard was 3.203 seconds. Once we had the averages, the real math began. With all of our averages, we were able to then go on and figure out velocity. In order to get velocity, you have to divide distance by the time. Running, for example, is 3.81 divided by 3.255. Skateboarding, on the other hand, was 3.81 divided by 3.203. Once we have velocity, we can move on to acceleration. As everyone knows, acceleration is final velocity minus initial velocity divided by time. Therefore, the final acceleration for the running is 0.36. As for the skateboard, the final acceleration is 0.3713. This shows that the skateboard accelerates faster, and therefore we need to implement this into a game engine for reality's sake. Thank you for watching.